Assalamualaikum and hi, my name is Muhammad Kamara Adam bin Kamal and I'm from class Dynamic DM13903 and I was in section 5 group 1. So we are going to explain about projectile motion, curvilinear motion, force, mass and acceleration, work and energy, and last but not least, linear impulse and momentum. So I will introduce to my fellow team, which is Amirul Haikal, Kamar Adam, which is myself, Iman Arif and Haikal Amma. So I will explain about projectile motion. Our situation is football, and the question is a ball leaves a 2.38 meter high from Cristiano Ronaldo foot with a trajectory to the ground is 5 degree. Predict the initial horizontal velocity if the ball falls to the ground 11 meter from the ball initial place. Okay. Firstly, we will subtract all the information given, which is vertical distance from ground to ball is 2.38 meter, horizontal distance from ground to ball is 11 meter, trajectory ball to ground is 5 degree, and we are gonna find initial velocity of the ball after the ball has been kicked. So we will use y-axis analysis first. So the initial velocity, which is uy, equal to VAY, which is VAY sin 5 equal to 0.087 VA, and the gravity for y-axis is negative 9.81 millisecond. For the distance, SY is SBY, which is 0 meter, and S initial is SAY, which is 2.38 meter, and the time we use TAB. So we will use formula SY minus S naught Y equal to UYT plus half AYT power 2. So after we arrange it, it will be 4.905 TAB power 2 negative minus 0.087 VA multiplied by TAB and minus 2.38 equal to 0, and that is equation 1. So for the x-axis analysis, initial velocity x is VAX, VA cos 5, which is 0.996 VA. For the distance, SX is SBX, which is 11 meter, S naught X is SAX, which is 0 meter. So SX minus S naught X is UXT. That is the formula that we will use. So we sub the information given. 11 minus 0 equal to 0.996 VA multiplied by TAB. So we'll get equation 2. TAB is 11 over 0.996 VA. So we will sub the equation 2 into the first equation. So after we calculate and after we sub and calculate all the information given, we'll get VA equal to 13.382 millisecond.
The Singapore Flyer stands at a height of 165 meter with a wheel diameter of 150 meter. The acceleration is 0.026 meter over second square. The Singapore Flyer completes 2 turns about its horizontal axis every hour. For question A, determine the velocity of the Singapore Flyer. For the question B, determine the time to reach a maximum velocity of the wheel rotational from the wheel rest. First, we need to sketch free body diagram. After that, analysis what formula we can use for solving this problem, and the value are given. We get the diameter is 150 meter, so the radius is 75 meter. The acceleration is 0.0626 meter over second square. They are given the Singapore Flyer completes 2 turns about its horizontal axis every hour. So 1 hour times 3600 to get the time in second. Then over 2 to get one complete rotational. The time is 1800 seconds. For question A, we use a formula velocity is equal to 2 pi radius over time. Enter the value of radius and time, calculate as usual, and we get the answer is 0.262 meter per second. For question B, we need to determine the value of an by using a formula. An is equal to v square over radius, and get the answer is 9.152 times 10 power negative 4 meter per second square. Then by using the value, determine the value of at using at square root at equal to square root a square minus an square, and we get the answer is 0.026 meter per second square. Then use a formula integration of v, calculate and rearrange as usual. Lastly, we get the final answer. Time taken to the wheel get maximum velocity is 10.077 second.
My name is Muhammad Iman Arif bin Abdul Hadi, number matrix AA221152. And now I will explain about force, mass and acceleration. Now let's say you are racing with your brother with a simple shopping cart for fun. Situation is in a supermarket. Your brother are pushing an empty cart which will easily leave you on behind. Now your cart are filled with grocery and are heavy. So you must find a way to accelerate the same speed with your brother even though your cart is heavy. So this question will ignore friction, and we need to find the forces needed to reach the same speed for 10 seconds. Your brother applied 20 Newton force to reach 18.5 millimeter per second of velocity. So what is your needed force to apply to a 40 kilogram cart B to reach the same speed as your brother? Okay, for the first step of this question is we need to subtract all the information given and find the necessary data for F equal to ma equation. So what we got is from cart A is F equal to 20 Newton and the velocity is 18.5. As for the acceleration is 1.85. So in order to use the F equal to ma equation, you need to convert the kilogram to mass. So 20 Newton times 1.85, which is acceleration, equal to 10.8 kilogram. Now use the same acceleration in cart B equation. So in cart B equation, we don't know the F, the force, but we know we need the same acceleration. So A equal to 1.85. So our mass will be M equal to 40 kilogram. Now use the same equation and insert it. F equal to ma, which is 40 kilogram times 1.85. So our answer is 74 Newton. So in conclusion, force needed to push shopping cart B to reach the same speed as shopping cart A is 74 Newton.
Hi, my name is Muhammad Iman Johar. I will explain about question work and energy. Our situation is lifting a barbell. In Tokyo 2020, Hidrin Diaz won a gold medal in women 55 kg category for weightlifting. She achieved an Olympic record and the gold medal after a clean and jerk of 124 kg with a mass bar 3 kg. She lifted the weight 184 cm from the floor. Calculate the need by Hidrin Diaz to lifting the barbell. The solution is, first we need to total all of the mass. The total of all of the mass is 127 kg. The distance is S1 is 0 meter, S2 is 184 centimeter. We have to convert a centimeter to meter, and the value is 1.84 meter. Okay, then we use the equation u1 minus 2 equal to negative 8 integrate s2 s1 ds. u1 minus 2 equal to negative w s2 minus s1. u1 minus 2 equal to negative 1 127 times 9.81 times 1.84 minus 0. u 1 minus 2 equal to 1245.87 times 1.84. The value that we got is 2292.401 joule.
Hi, my name is Muhammad Amerika bin Johar. Okay, I will explain about linear impulse and momentum topics. Our situation is car accident. The question is, the supercar with mass 1,380 kg traveled along the street, having an accident after hitting the tree. The velocity of the car was 150 km per hour before it's hitting the tree. Determine the impulse and momentum force of the car after hitting the tree. We can analyze the mass of the car is 1,380 kg, while the velocity of the car is 150 km per hour. The velocity of the tree is 0 km per hour because it's static. Impulse and momentum force is negative integrate FTT. The formula that we use is mass A times velocity 1 plus integrate FTT equal to mass A times V2. The plan is we use the principle of impulse and momentum to find the impulsive force of the car. First thing first, we need to convert 150 km per hour to meter per second. We just need to times the 150 times 1000 per 3600, and we can get the answer is 41.67 meter per second. Okay, next we have to insert the number into the equation. Mass car is 1380 kilogram times the velocity of the car, which is 41.67, minus integrate FDT equal to 1380 kilogram, and the velocity of the tree we just need to insert V3 equal to 0. Then we can get the final answer is 57,504.6 Newton meter.